I'm CK. Tonight we've got a little kit from the Dingdong Store. It's a memory trainer kit. I think it's going to turn out to be like a simple little Simon game, follow the colors type thing. Dingdong kit has been pretty good at beginner entry-level kits. Looking forward to putting this together, and I hope you enjoy the video. And here's the box, and that means we're upscale already on this one, because they usually come in plastic bags. Let's see what we got. Okay, a little promo for Dingdong Store kits. And again, I've had good luck with them. Memory training toy. Here's a QR code for a PDF of the build guide. Let's take a look at the build guide. Pretty straightforward, step by step by step by step. Introduction, start the game, LEDs light up in sequence, you need to match the sequence. Yeah, a Simon game. Sound and LED color prompt, 99 training levels, power saving mode, clear circuit marker so you can follow what's going on, and how to play with it, packing list, rest of the packing list. Looks pretty straightforward. We'll get the box ready for recycling. Now we'll cut open the bag. Take out the circuit board first. And there's another piece of paper in here. Let's see what that says. Oh, it says the same thing again in Chinese. Okay, so we've got, where's my pointer? There's my pointer. Looks like we've got some displays here, some resistors, a diode, and this is probably a button. I'm going to call these buttons. Some, that's LED, 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 LED. I guess this is a score. Some resistors, transistor, couple of more transistors, capacitor, output to a speaker, and the microprocessor, an STC, whatever, pre-programmed with whatever we have, and one surface mount part already plugged in, already mounted on the board, so if you've never done surface mount, don't worry, it's already done for you. And the board looks really good quality, all through hole-plated circuit component holes, which is nice. Here's the bag with electronic parts in it. Bunch of resistors. These are quarter watt. These are very, very small resistors. 9-volt battery connector. 2 7-segment displays. Some more resistors, diodes, disc caps, transistors, and the LEDs themselves. I'm going to go ahead and dump these all out in this tray. Make sure I get them all, because one diode was saying, I don't want to play. Yes, you do. And I think these are the buttons. That's one button, I think. The other, look at this. Look at this. Comes in a nice little case. Comes with a nice little case. That's pretty cool. And the speaker. Cheapy speaker, but what's this piece of? There's a piece of copper wire kind of hanging out here. I don't know if that's from the voice coil or not. I hope it's not damaged. I don't know if you can see that little copper wire here and here. Well, even if the speaker doesn't work, we'll be fine. A couple of pieces of wire to solder the speaker to the board. And then again, we've got, oh, that's nice. It's got the current score and the best score, I guess. I don't think it's got any storage SRAM. It doesn't have any continuously powered RAM, storage RAM. And these buttons, you can see it's got a little rubbery carbon thing here, which is going to press against these pads to bridge it to say you've pressed that button. Let's give that just a quick look. I just want to see what that's going to feel like. It's okay. It's a good solid press. Start and then the buttons. That's pretty neat. Again, you rarely get cases with these inexpensive kits from China, these training kits. So that's pretty nice. Other three buttons, so we have a total of 4. Then here we've got the microprocessor, and it comes with a socket. Again, many of these kits don't. They just have you solder the IC directly on the board. So this is a upscale kit from Dingdong Store. Looks like it might be fun. Simon games are always fun. So I'll get the soldering iron heated up, and we'll get this thing put together. So I pulled the PDF of the build guide up on my iPad, and I expect it'll probably have some pictures. Yeah, see, Dingdong Store does this pretty well. They put lots and lots of pictures in. So we'll go through those steps as one would if one were just starting out instead of being a bull in a china shop like me. Now the first thing we do is make sure that the music IC has been installed, and it has. Now we're going to put all the 100 ohm resistors on the board. These are these little quarter-watt ones. I'm gonna, because I always like to do this, because you never know for sure, we'll go ahead and make sure what the value on these are. These are 98.8, 100 ohm, that's just dandy. We'll do 1. Now because these are quarter ohm, they're very small, so you don't want to bend the leads right up against the body of the resistor. You want to give it a couple of millimeters on either side. And I was wrong. I think I said there weren't values on here. There are absolutely. The value for all the components is on here. So I'm going to solder one of these down to see how the board feels, how it takes solder and all that. Oh, very nice. Oh yeah, very good quality. So that's one, and I've talked pretty much all there is to talk about. And for resistors, which means I'm going to put the rest of these on without commentary in, and I'll put the video in fast playback. So it's resistor time. Alright, now we're back, and we'll go ahead and put the 2 diodes on. There's a white line here to show you where the black stripe on the diode goes, because polarity matters, of course, for diodes. I could find the other one. Yeah, it's almost a little too bad they left or already did the surface mount part, because that's a real easy chip to put on, and it might have been a good first time thing for someone to do surface mount with, but that's okay. It's not scary at all. No surface mount to do. Now we'll put the socket on the board and notch in the socket matches the notch mark on the circuit board. So the way I like to put sockets on is I rest the socket on my pinky finger. I do one pin, let it cool, take a look, make sure it's flat on the board and not at an angle at any way, and it is. So we'll go ahead and zap all these pins down. Now we've got the chip down, now we're going to do the LEDs. LED colors don't matter, so I mean the position of the LEDs for which color is where doesn't matter, but we'll take a look and see what color this one is using my meter in continuity mode. So we'll put the black lead on the short leg, red lead on the other leg. That's a red LED. Don't do that too long, just do it for like a second or two just to make sure the LED is actually working. Long lead goes in the positive side, marked with a nice little plus sign. I'm not going to look at the colors of the other ones, we'll just surprise ourselves and we play it later. Let's go ahead and solder these down. What I'm going to do, because these are slightly loose in their sockets, I'm going to just solder one leg first. I think I'm going to zoom down a little bit. I'm going to zoom in a little bit closer. I'm just going to solder one leg of each LED first. I'm going to pick the board up, take a look at it, see this one's not quite flat on the board, so I'm going to press on it with my thumb and heat that one leg I soldered up again, and there it goes. You might have seen it move a little bit as it flattens itself out against the board. That just moved a tiny bit, but this makes sure it's all flat on the board. Sometimes I don't care about that, but because it's got these rubber-like buttons, the LEDs really need to be centered so they're not interfering. And that got all of them. Now I'll do the other leg. Now we'll put these 104 tenth of a microfarad caps on. They're power smoothing caps for the IC to make sure it's got for both this IC and the smaller surface mount one, to make sure power doesn't sag or go too high. Where does the next one go? Oh, it goes all the way over here. Whenever you work with anything that's got ICs, you're going to find a lot of tenth of a nanofarad capacitors scattered around the board. Now we've got a S8550 that we want to put in here. It is not an 8550. It is not an 8550. And that is an 8550. And it goes over here. It's getting a little messy back here. I'll solder this stuff down and trim some leads off. Now you may notice that the lead holes for these transistors are wide apart, so you will not have too much issue with potential of bridging contacts, so don't worry about that. I should say worry about it, but they've made it easier to not make a mistake. Now we're going to do the 9013, and of course I picked 50 chance and I got it wrong. 9013 goes over here. And by process of elimination, the 7550 goes over here. And again, I'm just double checking because sometimes things pack wrong. It has happened. I'll solder them in a little bit. Now we'll do the big electrolytic. This is 470 microfarad. Now the shaded portion on the circuit board is the negative side. That is pretty much a convention for circuit board software that uses shading. And same thing here. So the short leg goes in the shaded side. Now let me zap these down. I'm going to grab another piece of solder. Next we'll put the digital displays on, and we want to have, oops, pin is bent a little bit. Let me straighten these pins out just a little bit and get them lined up. We want to have the dots at the bottom. I didn't get it quite right. Let's see if I can get them in there without. Yep. That's one. Let me check the pins on this. That looks better. There we go. Same drill as for the socket. We'll do one pin. And pick it up, take a look, make sure it's all flush and flat, and it is. Now we'll put the IC in the socket, and I'm going to press them against the side of my workbench to get the legs in more perpendicular to the body so it goes into the socket correctly. Got a notch here, notch there, that's what we want. Make sure the legs will go in well. Nope, I gotta bend them in a little bit more. I think they're all good. However, I'm going to demonstrate something that, or just do something that, if you're ever concerned about whether a IC is fully seated, go ahead and get this in my pan of ice for a minute. I'm going to take my meter, which is still in continuity mode, and I'm going to touch the pin and the solder point on the back, and that means I can see if each pin is fully seated, making good contact. Again, you don't have to do that ever. I like to do it sometimes when I'm not absolutely certain that a chip went into a socket correctly. And now we're going to put the wire on the speaker. And there is no hole on the pad, like on many speakers. So what we'll do is we'll put some solder on the pad, like so. Now hold our wire. Rest our wire on top of that solder ball I just made. Heat it up again. And the wire, if I could stop jerking my hand around, and the wire settles in there, and it's soldered up. Eight-ohm half-watt speaker. So obviously it's not going to be very loud. There we go. Now we'll put that on the board. Speaker is there. The speaker is not polarized. The markings on the board show polarization, but if for a device like this, you're not going to, phasing and so on is not going to be an issue, so don't worry about that. And they're clear to point out in the guide that it doesn't matter. Speaker is on board now, and now we'll do the battery connection. Now this, of course, it is very important that you put the red wire in the plus and the black wire in the minus, because if you don't, nothing's going to work and you will be sad, and we don't want that, do we? Okay. Huh. That's interesting. They recommend that you use the little bag that the speaker came in to put the speaker back in, like so. I think you can see that. So that when it's mounted in the device, the PCB spikes don't actually, like from that socket, don't actually touch the back of the speaker and ground it out. I'm not going to use plastic bag for that. I will use some electrical tape, because plastic bag is not quite dense enough for me to be comfortable with it being a good insulator. I'll just put one, two pieces of electrical tape on it, and we'll be fine. Now we're going to mount it all. We're going to put the speaker in that little hole, like so. Push it down really nicely. And then Am I doing? No, gotta go that way. Gotta go that way, guy. We'll fit in there like so, and then we've got some screws. Screw it all together. You don't want to tighten it too much because it's metal into plastic and you could strip the plastic easily, so don't gorilla hand it, just tighten it snug. And just use one screw. Now I'll put a 9-volt battery in, test it against my tongue to make sure it's got good charge. Plenty of charge. Buzzing on my tongue. I've been doing that since I was like 8. That's how I test 9-volt batteries. Wow, this battery snap is a little big. I have to shove it a little bit to get it. I'm surprised since that's such an industry standard. Okay, we'll drop the battery in. Oh, you want to go this way. It wants to go this way. Not a lot of space here, but it'll be fine. Now we'll tuck the wire in, kind of like so. I'm going to pull the film off the displays. Okay. Now we want to put the buttons. No glue needed. Just guide them into their little holes. If you can. And again, just to be clear, this is carbon impregnated plastic, and when you press, it's going to bridge these contacts to turn it on. That's used a lot in consumer electronics. If you were to take apart a PS4, a PlayStation, or an Xbox controller, all the buttons on that are the same. They are little carbon buttons going onto pads on a circuit board. They're very robust. And now, put the case on and make sure we got the wire. It's probably going to be the hardest part, is making sure that wire stays in and doesn't interfere with getting the case closed. And the battery connector itself is poking out, because again, it's not quite the right size, but that's okay. Get it all together. Take these little screws. Okay, it's theoretically ready to go. Let me turn this overhead light off and press start, and look at that. As you can see, some of the segments on the multi-segment display are not lit. I'm going to take this back apart and make sure I've got all the solder connections right. So first I'm going to look at the resistors. All the resistors look good. And on the back, no, they're all right. They're all soldered correctly. There's no bridging. There's no bad solder joint. I think the segmented display may just be not great. But it doesn't matter. I'm not too worried about that. Screw this back down. Yes, I'm sorry. I didn't mean to turn you back on, little machine. I apologize. But you might have noticed it does have a timeout circuit. So there's no off switch. When you're done, you just stop playing and it'll time out. It's got a counter inside the microprocessor, and after a certain count it'll turn itself off. Gosh, buttons are playing with me. Okay, back to what we did before. Now, one little tip on doing steel into plastic screws or metal into plastic self-tappers, you don't want to just charge ahead and screw that all down again. You want to go counterclockwise a little bit, and I don't know if you heard that, it clicked a little bit, indicating that it reached, you could feel it, it reached the way the threads had been cut the first time. So we're going to use the same thread in the plastic as we did when we first did it. There. Instead of cutting a new set, which makes, if you are going to take this apart more than once, if you're going to change batteries or so on in the future, you won't be weakening the plastic. Again, we put the screw in there. I got to get put the screw in there, go counterclockwise. There, it clicked. That means I just rode the ridge of the original screw threads, and I can use them again. And that's true for any self-tapping plastic screw hole. Just do that and you'll be able to take it apart and put it back together quite a number of times without it stripping out. Let's play again. And on and on. And one thing you might also notice here is that those patterns are different than the first time I ran this, meaning it randomizes it. You can't memorize the patterns that are going to be coming up each time, so it's more fun. Every time's going to be a different challenge for you. So I will say, okay, that's when you do it wrong. Let me do that again. That's pretty neat. Now the segment's back. Now the segment's... Did it wrong. Back to the beginning. So again, this is a good little kit. I'm very pleased with both the quality, except for the display issues, but the quality of the build, the fact that it comes in a little case, the randomness of the order of flashes, which makes it more challenging, the quality of the buttons is good. All in all, this is a really good kit. Congratulations to Dingdong Store for this one. If you get this, again, it's relatively simple to put together. I think you'll have a really fun time with it. Hope you enjoyed the video.